They say Karel has to pay a loan of 75,000. He can afford to pay 1,500 per month at an interest rate of 16.2% compounded monthly. How many payments will he have to make? Ne? So they want to know how many payments he's going to make. They didn't say how many payments of 1,500. They said how many payments this person is going to make. Ne? So how do you approach this question? Let's collect our data first. We have the present value. He wants to pay up a loan of 75,000. So that is going to be our present value. And then we have X, which is going to be 1,500. We have I, which is going to be equaling to 0.162 divided by 12. And then from here onwards, we can start to play around with the formula. So we have present value, which is X. And then we have 1 minus 1 plus I. Minus N, close bracket. All over I. So what are we looking for, Tine? We're looking for N. Since we're looking for N, here's what I'm proposing. I'm proposing to let us, first, let's multiply with I both sides, and then we have I, P, V. Ne? And then from here onwards, we divide by X. Ne? So if we divide by X, what is it that we're left with, We're left with 1 minus 1 plus I to the power of minus N. Ne? Now, what is it that we're going to do? Here's what I'm proposing. I'm proposing that we take this whole bracket, which is negative, to this side. Ne? But at the same time, let's take this person to this other side. So what is it that we're going to be remaining with then? We're going to have something that looks like this then. We're going to have 1 plus I to the power of minus N, which is going to be equaling to 1. It's 1 minus. Ne? 1 minus I, P, V, all over what? All over X. So we have the following. Ne? And then from there onwards, we said we want to get N. But you can already say we can't get N. We can definitely get minus N. So I'm going to say, let's maybe start here and say we have minus N, which is going to be given by the log. And then we have 1 plus I. And then we have the bigger bracket. It's 1 minus I PV all over X. Yes, Scott. We can derive that thing to be.
I see derive it. Okay, do it to be 1 over 1 plus I.
You do this thing to be all over.
I like that thing, even to the power of -1 and outside.
You want to write it as 1 all over.
Yes.
And then it's 1 plus. Yeah, we can still do that. We can, from here we can divide both sides by negative. If you put a negative here, then you're going to have this whole thing here, it's going to be minus. The answer that you're going to be getting here is going to be negative. So let's go and check that now. Let's go and substitute and check if we're getting our answer correct. If we don't get it correct, this one, it has a tendency of having maths error to show you which you did something wrong. So we have log. We have 1 plus, what did we get as our interest?
0.162.
0.162 divided by 12. No? Close brackets. We have 1 minus 0.162 divided by 12. No? Multiplied by 75,000. All over 1,500. No? Yeah, let's check how do we type this in our calculator. I think this one, let me show you first, and then we'll do it. So we have the log, no? And then we have open bracket. We have 1 plus. We have 0.162, no? All over 12. Close bracket. And then we have 1 minus fraction and the fraction again is 0.162 all over 12. Then we multiply this by 75. 1, 2, 3. Ne? And then we have what? 1,500. Like this, ne? Equals to. We get minus 83. English. So we have minus, and so automatically I can tell them with negative and a negative, ne? Because the answer is supposed to be positive. So I'm going to tell them which minus n is going to be minus 83, 81. Ne? Therefore, it means which n is going to be equaling to 83,81. Now they ask me how many payments am I going to make, English? I'm going to tell them I'm going to make 84 payments. Ne? So the total number of payments that I'm going to make is going to be what? To be 84. Now, I want us to take this opportunity and introduce the last, the next topic that we're supposed to do. The next topic speaks about what is the last payment that you're going to make. If it's not 1,500, you still have to make it, but it's not going to be what to be 1,500. So if it's not 1,500, what is it going to be? And then how did we get that? We speak about something called the last payment. Ne? Now, for us to understand the last payment, this is what we need to understand. We need to understand something about the timeline. So I'm also introducing it here. So on your timeline, you have T0, and then you have 84 payments that you're going to make. All in all, the number of payments that you're going to be making is what? It's 84. Now we have something called an outstanding balance. Yeah? Now, what is going to be the outstanding balance? Basically, outstanding balance, it works with the outstanding months. The present value, the money that you got here, the 75,000 here, when they were asking us how many months are still outstanding, we told them which there's still outstanding months, which is what? Which is 84. Then I can also ask you something like this. I can say, let's say you've paid for 12 months. Ne? If I ask you what you have paid for 12 months, what is going to be the new present value just after the 12th month? How do you get what is going to be the outstanding balance exactly just after the 12th month? You need to ask yourself, how many months are still outstanding? Because the present value, basically, it works with how many months do you still have to pay. So how am I going to do that? I am going to say that I have 84 minus the 12 that I've already paid. And then I am going to tell them which n is going to be what? To be 72. So the present value, if they were asking me to calculate the present value just here, instead of using 84, I was going to use what? 72. Why am I using 72? I'm using 72 because 72 is still what? Outstanding.
We use the same formula.
Yeah, we use exactly the same formula. The only thing that is changing are the months that are outstanding. I will still find them. So look at this then, Khots. If we're using that same principle, we're telling them 83 of them is 1,500. 83 of them is 1,500.
Yes.
There is a 0.81, which is still outstanding. That one. So how much is still outstanding? It's 0.81. How would I get this 0.81? I am going to use the present value formula. Yeah?
Yes.
If I use the present value formula, instead of n being 84, is going to be 0.81. But that's not the money that you're going to be paying. That one is just the outstanding amount.
Yeah.
You don't understand it.